Hello there, greetings to you. So in this video, me and my friends will talk about HPLC, which is high performance liquid chromatography. Also, in this video, there will be a demo about a practical video of HPLC that we'll get to see in the video later. So first thing first, let's go and find out about what is HPLC and also their importance. Let's go.
High performance liquid chromatography, or HPLC, is defined as a separation of a complex mixture. The complex mixture can be separated into two types of phases, which are mobile phase and also stationary phase. Mobile phase is the liquid that dissolves the target compound, while stationary phase is the part of a column's component that engage with the target compound. Importance of HPLC. In the pharmaceutical sector, all of the products must be of the highest quality in order to ensure the lowest risk to the patient. HPLC plays a crucial role in pharmaceutical industries and analysis since it is used to test the products and identify the raw materials that are used to make them. For example, qualitative and quantitative analysis. HPLC is a useful analytical tool for determining the components of a drug's formulation, and it allows the researchers to quantify the formulation and discover if there are any impurities in the product. It is possible to use HPLC for routine quality control analysis of drugs in bulk and pharmaceutical dosage form because of its simplicity, specificity, rapidity, preciseness, and accuracy. These advantages of using HPLC beyond not only on synthetic drugs but to herbal remedies also.
And now we know about it. Let's see about its principle.
Now we move to the principle of the high performance liquid chromatography (HPLC). Purification occurs in separation column. First is stationary phase and second is mobile phase. Stationary phase is a granular component with a small porous particle in the separation column, and a mobile phase is a solvent mixture that is pushed through the separation column at the high pressure and act as a carrier to the sample solution. There are two techniques in the mobile phase. First is isocratic elution and second is gradient elution. Before the process starts, degassing of the solvent should be done in order to prevent the bubbling of the gas and the air caused from the high pressure because it may damage the stationary phase. This technique can be done by warming or the vigorous stirring with a magnetic stirrer. Then the process of HPLC goes as they travel according to their relative affinity toward the stationary phase. The component that has the high affinity toward the stationary phase will go slowly, while the component that have a low affinity toward the adsorbent will go faster. From that, it proved that two components have a different affinity toward the adsorbent, so that the component will be separate. After they leaving the column, the separated components are detected by the suitable detector, then pass on the signal to the HPLC software on the computer.
Okay, now on to the next part, which is about the HPLC instrument.
Modern high-performance liquid chromatography (HPLC) uses high pressure to force mobile phase and an analyte through a closed column pack with micron-sized particles, which constitute the stationary phase. HPLC instrumentation is made up typically of 9 basic components: mobile phase or solvent reservoir, solvent delivery system, sample introduction device, column, post-column apparatus, detector, data collection and output system, post-detector eluent processing, and connective tubing and fitting. All components except for the post-column apparatus are essential to performing HPLC. As for HPLC, the pump delivers the mobile phase under the standard atmospheric pressure in which we live in. If the mobile phase contains air bubbles and enter the delivery pump, troubles such as flow rate fluctuations and baseline noise or drift may occur. The degassing unit helps prevent this issue by removing air bubble in the mobile phase. After the dissolved air has been removed, the mobile phase is delivered to the column. The sample ejector then introduces a standard solution or sample solution into the mobile phase. Temperature fluctuations can affect the separations of compound in the column. The column is placed in a column oven to keep the temperature constant. Compound eluted from the column are detected by a detector which is placed downstream of the column. A workstation processes the signal from the detector to obtain a chromatogram to identify and quantify the compound.
Now we know all about HPLC, so now let's go and watch the method used in HPLC.
Turn on the left button on each module of HPLC system, starting from the solvent pump, vacuum degasser, auto sampler, column compartment, and the detector. The detector that we are going to use in this practical is UV-Vis light detector, also known as DAD. And then launch the Open Lab CDS software in the computer. For the degassing method, set 50% solvent gradient for both A and B. Mobile phase that we use in this experiment, commonly acetonitrile and water. This method is to eliminate the dissolved gas from the sample. And then turn the purge valve in the counterclockwise direction to get rid of the large bubble in the system. Moving to the column compartment, first we need to open the column compartment to ensure that the right column is being installed in the system, and detach the holder of the left column compartment to get rid of the leftover liquid from past or previous practical. Next, in the auto sampler, load sample in the well of loading tray correctly and place vial containing only 0.5 to 1.5 ml of sample to obtain an efficient sampling. Then, set sequence and run the sample. The auto sampler will inject the sample automatically into the system. Lastly, the UV-Vis detector will receive signal from the components in the sample that has the highest affinity towards the mobile phase to be eluted first, followed by the component that has the highest affinity towards the stationary phase to be eluted later. This will form peaks in a chromatogram. As we can see, the x-axis shows the amount of time to pass through the column and to reach the detector. Meanwhile, the y-axis shows the amount of analyte present in a sample. There are few types of sample used in HPLC. HPLC is commonly applied to analyze the component in the biological specimen, such as saliva, blood, and urine, and also to analyze the environmental specimen and also medicinal chemistry such as drugs.
We've come to the end of this video. I hope you understand of what we are explaining, and I hope you know more about HPLC now you've watched the video. So that's all from me and my team members. Thank you for watching. Bye!